All right, last but not least, this is the big one, kind of the one for all the marbles, as it were, because this is the thing that really we're going to be using to be able to create our stop motion animation. We need to be able to figure out what's going on here with this delta x. Now, delta x, the delta always means change in, right? So this is a change in something. What does this x represent? And the answer is the position in the x direction, right? And we've got this car that's starting off on this side, and it starts off a little bit, and then it gets a little bit faster, and 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 off it goes. So this is my change in position, right, in the x direction. So what I would look at here is I'd say, hey, what is my change in position in the x direction? Well, this is going to be equal to, and I'm going to just use this piece up here, which looks like alphabet soup, but will get easier as it goes. So I'm going to go ahead and put in this 1/2, but I'm going to change it into a decimal so that I can use a calculator to get me there. So I've got 0.5, that's my 1/2. And then I'm going to put in my acceleration. And my acceleration we already know, which is the 0.067. I'm going to put in the units on it because that's important to write them. So that's centimeters per frame squared. All right, so there we go. And then I'm going to put in my time, but I'm going to put in my time here just with the letter T, because this is going to change for each of our frames. And since we have to do this kind of repeatedly using all of these frames, I'm just going to leave it as T for the moment. We'll change that soon. The second piece to this says, okay, we're going to add on to it whatever your velocity that starts with times your time. So my velocity that things start with is 0 centimeters per frame. Oh, I can see where this is going, because I'm going to multiply 0 centimeters per frame times T again. But here's the crux of the situation, right? If I multiply 0 times anything, it doesn't matter what T is, 0 times anything, this piece right here goes away, and we can say it's become 0. It's gone. We don't even have to worry about it anymore. So the only thing that's left over is this part right here, which is 0.5 times 0.067. So let's take a quick look at kind of what that is, and we'll replace this 0.5 times 0.067. I'm going to come over here to my handy dandy kind of Google calculator, right? So we already saw that 1/15 is this 0.067. Now I've rounded a little bit here, but then I would take this amount, right? And I'm going to multiply that times 0.5. And if I do that, I get 0.033. All right, so let's go back over here and put that in, because we're going to replace this piece right here. Actually, let me grab my blue again. And we're going to replace this part right there, all of that, by this 0.0333333 repeating. So I'm just going to leave it like that for the moment. And I'm going to say that I'm going to multiply that times some quantity T squared. So this whole thing is becoming much simpler. My delta x is nothing more than 0.03 times T squared. All right, that's pretty easy. Now, what if we start with T equals 0? Well, if T equals 0, this whole thing becomes 0. So we can think about it here and say, well, if T equals 0, so I've got 0.03 times 0 seconds, excuse me, or 0 frames, I suppose is a better one, because we're at frame 0, right? And even if I square that, 0 frames squared is times 0, so this whole thing becomes 0. When T equals 1 frame, or kind of, as we're looking at it, then we end up with this new one, so this is different. And now if I take on this, I get 0.03 times 1 frame squared. All right, so 1 squared is 1 times 0.03. So we've got a few pieces of information that we could start storing down below. And that down below that I'm talking about is right here in the table, where it starts out at 0, and the next time is just 1 times 0.03. So our number is 0.03. 0.303 centimeters is where we put. This is a tiny, tiny number. This is almost zero, but it's close. So what happens when we get to the next one and we're saying, okay, well, what if we're not doing one frame, we're doing 2 frames? Well, if that's the case, then at 2 frames, we've got 0.03 times 2 squared. And I'm going to leave off the frame for just a moment as things go. 2 squared is 4. And so 4 times 0.03. Maybe we can do that on our head, but let's come over here to our handy dandy calculator and put that in here. And we'll say 0.03 times 4. And I get this 0.12. All right, so we're getting on there. This is good. Now this is starting to feel similar to this side, but it's going to change here in just a moment, and you'll see what I mean. So 0. Oh, I always want to change colors. Let's put that back in blue. So that's 0.12. What's the next one? Well, now instead of it being 2 squared, it's the third one, so it's going to be 3 squared. So 0.03 times 3 squared. So let's do that. And 3 squared, 3, let's do just a 3 squared right here. And we'll put it in there, and we walk away with this, 0.27. All right. So now we're going to plug that one in, and we've got 0.27. Now that is starting to look different from this side along the way. So here we go. We've got positions that are starting to creep up here and velocities which are adding up by this point. And I've done kind of as much as I want to do by hand. So I'm going to flip over and take a look at how to use a spreadsheet to fill in these numbers so that we can make this whole thing make sense a lot faster. And I'll show you that in the next video. All right, peace.